Welcome to the Engerati studio. I'm Rose Bundock and I'm joined by Daniel Quant, Vice President of Product Management at MultiTech. Welcome, Daniel.
Yeah, thanks for having us.
I understand MultiTech knows a thing or two about connectivity.
Well, yeah, we've been around now since, 1971. Company cut its teeth with analog PSTN connectivity, inductive couplers. Perhaps you've seen in old movies, put the handset down and you can hear it bleeping and it's communicating with something. Obviously from that it went to a more integrated solution. We built analog modems for a ton of different use cases, and as we moved into the 90s and into the 2000s, broadened our portfolio to wireless technology. And the last 3 or 4 years we've heavily invested into low power wireless access technologies, both licensed with technologies like CAD-M and narrowband IoT, and unlicensed band technologies such as LoRa and LoRaWAN.
Great, well you're well positioned for us to dig a bit deeper into those utility use cases. I mean, obviously we're seeing, in the telecom sector, they've managed to overcome that challenge of connecting a vast number of devices. How's the utility sector doing in comparison?
Yeah, so that's a good question. So there's essentially 3 types of wireless communication. There's these local networks like Wi-Fi and Bluetooth that would cover a room like this, or perhaps even a part of a convention center that we're sat in here today. But they would struggle to cover a whole convention center. And anybody who has Wi-Fi in their house knows that they often struggle in the back room to get a decent signal. This was typically more of a capex expense. You perhaps go to the shops, you buy a Wi-Fi access point, you turn it on, it works, it's a capex investment, there's no OpEx cost. In order to get that wide area coverage where you really could cover a whole exhibition center, a city, a country, a world even, cellular technology has really in the last 10 years made phenomenal inroads into that market. But of course, this becomes a very OpEx-driven model. The cost of connectivity and equipment starts to climb a little bit, and that return on investment can take longer, and in some use cases it's perhaps prohibitive. And this is where low power wireless steps in. It's a bit of a paradigm shift in a way, because you get the ability to scale the technology in a capex method, just like you would Wi-Fi or Bluetooth, but you get wide area coverage that you typically had been able to only get with cellular-based technologies. So here today in Amsterdam, there's at least 2 networks. There's a KPN network that's covering the whole of the country here for LoRa, and then of course the Things network, which has a community-based network that's very strong here. So that's a good example of how low-power wireless access can perhaps connect more assets in different use cases using a high capex-based approach, or perhaps an OpEx approach, depending on the use case.
Do you feel there's sufficient clarity in the sector about which use case should apply to which connectivity solution?
So there is great debate in this industry about which technology reigns supreme. The amount of presentations that I see where it's cellular versus LoRa or versus Sigfox or some other technology. And for us at MultiTech, we never saw this as a competition. I jokingly refer to this as the Highlander model. You may remember from the movies, you had to chop the heads off of all of these guys, and then the last one standing would win and be immortal or mortal or whatever. But it's not a Highlander model. When you combine these technologies together, you get far more than this concept of winner takes all, or one technology can reign supreme. And this isn't a consumer market, it's an industrial market. There are many different use cases. To imagine that one technology could somehow be better than all technologies for every use case, it's just not the case.
From an operational perspective, for a DSO, I imagine they're thinking, I hope there is one that we can roll out and run everything off. But obviously, as you say, it makes sense to combine. How does that actually work in practice?
Well, so here in the utility business, here at European Utility Week, we see an incredible amount of fracturing of connectivity technology. There's every possible technology here that you've ever heard of and loads that you never have, right? And a lot of proprietary technology. And increasingly, the utility business isn't just serving a single silo. Increasingly, the utility business is looking to open up use cases that are more municipal, like EV charging, for example. And as they open up to new use cases, having proprietary technology doesn't give the interoperability and the volumes of scale of the industry. Some years ago, the industry was much more focused on one provider providing them a whole turnkey solution, I guess, because there's none of this going on, right? They know who provided it to them and they support them through the life cycle of that technology. And there's benefit to that, but of course the downside is the lack of interoperability and the lack of vendor choice and often vendor lock-in. But now I think we can see with low power wireless access, different types of technologies that are now scaling, they're more interoperable, they service a broader set of use cases, and that complete fracturing of technology in this industry, I think will start to get rationalized as we look ahead.
So obviously in Europe, energy suppliers are facing the clean energy package requirements. How do your solutions fit into that? How are you helping companies to comply?
So, so one of the areas where there's change and there's more openness to new approaches and different ways to do things is exactly in those kind of energy areas, such as smart green energy, distributed energy resources is another good example of that. So we sell to a number of companies that do solar panel inversion of sunlight to electricity, and metering that back into the grid, distributed energy resources so that they can store energy at times when electricity is cheaper and more plentiful, and then be able to push that back into the grid when the spot price goes higher, when the demand is higher, and when those coal-fired stations are having to be woofed up in order to meet that kind of demand and response. And I think here today at the show you see a lot of push now in this distributed energy resources to address exactly that. So whereas connectivity was originally in place to do monitoring and make sure that service level was being achieved, that nobody was lacking electricity, now you start to see the second wave of use cases coming through where the asset is actually being controlled to bring back electricity or store electricity to minimize the carbon footprint from more traditional ways to create energy.
You mentioned narrowband IoT. I know there's been a bit of feels like more interest in that this year at the event. What kind of use cases specifically for that technology spectrum could you tell us?
Yeah, so good point. And you see a lot more interest for it this year because it's a lot more realer. For example, this year MultiTech has tested with all of the big operators out in Spain, the UK, and mainland Europe. In fact, we did the first narrowband IoT public demo of narrowband IoT in the Americas, in North America, about 3 weeks ago with T-Mobile. So now you're starting to see a lot more reality, and so the market is taking that more seriously. A great use case for narrowband IoT is connecting assets that are more distributed. One of the big values of a cellular network is that you have a lot of cell sites, and you can bring that technology to market very quickly when you've made a conscious decision to do it. If you look at AT&T and Verizon with their LTE Cat M1 networks, it took them no more than 6 to 7 months to go nationwide in America, which, as we all know, is a very large country, right? So they went nationwide within barely more than 6 months, and by having that ubiquitous connectivity, you can address assets that are very diffused out there into society. And metering, particularly electricity metering, for example, is a great example of that, because electricity meters are in every village, town and city in the country. So having regional coverage doesn't really help you when you're trying to cover a whole county or a state or a country even with metering.
So do you get a sense that DSOs are perhaps looking at the results of these pilots, a bit of a wait and see how, what are they doing? Are they find it hard to make the decision basically on which is the right
There's a lot of
them?
paralysis by analysis. I have many meetings with customers who can see the benefit in technologies today, but that story of what's coming, it was so much better in 6 months, and even Cat M1 and narrowband IoT, and LoRa, they all have roadmaps on them. They all have more features coming tomorrow that are so much better than what is there today. And so a lot of customers, they get stuck in this paralysis of analysis. Where do I go? If I could just wait another 6 months. But one of the things that this industry is great at is explaining what's coming around the corner. But by the time you get round the corner, your expectations will be so much higher that, if I could only just wait another 6 more months, it would be even better again. And so we have a number of customers who really suffer from that paralysis. And then, of course, there's the comparisons of the technology and that whole Highlander model and vendors putting more and more information out there for their technology to win. As the name would suggest, at MultiTech, we have a lot of technologies, and we see them less as competitive and more as in better suited to particular use cases or financial models that customer may want to enjoy.
Thank you, Daniel. Thank you for explaining your approach and more about the communication technology. Thank you for joining us. That's all we've got time for in the Engerati studio. You can watch plenty more of our videos on the Engerati YouTube channel. Thanks for watching.